onwards with the FRQs. Number 5 is doable. Kind of a hassle. You better have your algebra skills up to speed. But mostly it's just an RTFQ thing. So let k equals 3 on this nonsense up above. They're very nice derivative for you. If you get a chance, you should do it also. Make sure you're cool with it. Now k equals 3, that means this equals 3 minus 2x over x squared minus 3x squared. We're an equation for the line tangent to the graph. So this becomes 1 over x squared minus 3x. Plug in x equals 4. We get 1 over 16 minus 12, 1/4. So for a, y minus 1/4 equals x minus 4. And we plug x equals 4 into here. 3 minus 2 times 4 over 16 minus 12 again, squared. 3 minus 8, negative 5 sixteenths, negative 5 sixteenths, and they do like it as y equals. I just did these, so I'm going through them pretty quick, so don't get frustrated if it's taking you longer. Now, k equals 4, so let's erase this and this. I'll leave that and all this, so no idea where this is going. And changes to k, 4 minus 2x, x squared minus 4x if I need that. So blah blah blah, fx equals that. Determine relative min. Well, we're going to take the derivative, 4 minus 2x over junk, because I don't care, set it equals 0. That means we just worry about the numerator. 4 minus 2x equals 0, 4 equals 2x, x equals 2. 2, plug in 1, and we get a positive slope, and the 1 goes in here. The basement denominator is always positive, so all we have to do is plug in 1 on the top, and we should get a positive number. We do. And then plug in 3. Again, the denominator is always positive, and the top in this case is negative. So we have a relative max at x equals 2 because slope goes from positive to negative at x equals 2. That's your reason, that's your justification, in case you're wondering why I wrote that. C, find the value of k for which f has a critical point x equals negative 5. So we don't know k, so we're up here, and we want a critical point, so we're taking the derivative, k minus 2x over x squared minus kx squared, and we set that equals 0. And then it says find the value of k at x equals negative 5, so we plug in a negative 5 here, negative 5 here, negative 5 here. Wait, that's right, we don't care about the denominator, just the top. So k minus, something is bothering me now. Nope, 2 times negative 5 equals 0, k plus 10 equals 0, k equals negative 10. And last but not least, D, which I need more space for. Let's go do partial fractions. 1 over x times x minus 6 equals a over x plus b over x minus 6 multiplied by x times x minus 6. 1 equals a times x minus 6 plus b times x. Imagine x equals 0. A would then equal negative 1/6. Imagine x equals 6. B equals 1/6. So now we want to find the integral, knowing that all this nonsense is true. Negative 1/6 over x plus 1/6 over x minus 6 dx equals, I'm going to factor out the 1/6. Negative ln absolute value of x plus ln absolute value of x minus 6 plus c, and then I'm going to try and rewrite this here, equals 1/6 ln x minus 6 over x plus c. Don't recommend making it quite that messy for the poor people at the College Board. All right, and our best friend in the world, the infinite series question. I say that with a little bit of sarcasm, but I found this one very doable. Ratio test. Ratio test, limit as n goes to infinity. Absolute value. I am going to break this piece up. Negative 1 to the n minus 1. 3 to the n minus 1. I've already forgotten to add plus 1s in here. Plus 1 minus 1 plus 1 minus 1 over n plus 1 times x to the n plus 1. Flip everything, so you have an n over here and an x to the n over here, and a negative 1 to the n minus 1, and a 3 to the n minus 1. Now down here, I'm going to say absolute value of, I'll put the limit in because it couldn't hurt, negative 1 to the n over negative 1 to the n minus 1 equals 1, and the limit as n goes to infinity of n over n plus 1 is 1, and then I will cross the rest out on the fly. X cancels there, and 3 to the n, basically the 1 negative 1 cancels out with this, and I am left with 1 over 3 to the negative first and an x, which is 3x. Absolute value of that is less than 1. Absolute value of x is less than 1/3. R equals 1/3. Goofy stuff. Gonna go up high so I can keep an eye on things here. Write the first one and zeros of the derivative. All right, that's easy. Here's your f of x, therefore f prime of x equals sum n equals 1 to infinity. Nothing's changed. Negative 3 to the n minus 1. Nothing's changed. And then x to the n minus 1 over n. Cancel, cancel. So plug in 1 and we get 1. Plug in 2 and we get negative 3x. Plug in 3 and we get 9x squared. Plug in 4 and we get negative 27x to the third. Piece of cake. Only problem is we actually kind of need that for the last part, so I'll see if I can leave it up there. And it says, write out e to the x. To which you should say, seriously? C. E to the x equals 1 plus x squared, 2 factorial plus x to the third, or 3 factorial. And then knowing that this is, actually that's f prime of x. I don't need that. What I do need is what they gave us. F of x equals x minus 3fx squared plus 3x to the third. F of x equals x minus 3 halves x squared plus 3x to the third. Now, go ahead and multiply those. I don't have to do anything over x to the third because that's all they asked for. So e to the x times f equals, first with the 1, x minus 3 halves x squared plus 3x to the third. Then with the x plus x squared minus 3 halves to the third. Then with the x squared over 2. I don't really need the factorial. And that gives us x to the third over 2. Add them down, and you get x minus x squared over 2 is 2x to the third. Like I said, I thought the infinite series for a change wasn't so bad, but don't kid yourself. That's all tricky stuff. Make sure you know your e to the x. I've seen that question a lot. Good luck.